Okay, we have here something interesting from the MIT Integration Bee 2025, number 8. We have the integral from 1 to 2, 2 to the x minus 1 plus log base 2 of 2x dx. So this is actually my second attempt at this one. I recorded this and I did it out the long way. I broke it out into two integrals and just did it out. They're not that bad. I mean, each integral separately is pretty easy. But then at the end, I was really thinking about it, and immediately after I finished the video, I realized there's a shortcut for this. Basically, to show how you could do it if you were in the Integration Bee and you were really in a hurry, just splitting it up like this, what you can do is you can multiply out the bounds. You can do 2 times 2 minus 1 times 1, just multiplying the bounds here and here, and 4 minus 1, this is 3. So this is the way to do it in 2 seconds or 3 seconds. But in reality, if you're not an Integration Bee, you're going to want to understand it and kind of see how this works. And you have to do some checks actually. So I don't know, you can't really do all the checks in 3 seconds. So let's just look at the formula I used in order to do this. Okay, so I derived this formula just like a week or so back, and it involves the inverse. So the key is it's not just going to work on any integral. What we need is, if we're calling this thing our f of x, then we need this thing to be the inverse, f inverse of x. And we also need the bounds to line up as well. So I think the first thing we need to do is we need to verify that these are inverses. So if this is our f of x, let's write this as y equal to 2x minus 1. So in order to get the inverse, I should be able to just solve for x on this and then switch the variables. So I can let's take log base 2 on both sides. So what we have is log base 2 of y, and then we'll have on the right side log base 2x minus 1. And then I can use log properties here and bring this in front. So we have x minus 1, and then times log base 2 of 2, but of course this is just 1, so this goes away. Then from here I can just add 1 on both sides. And so now we've isolated our x. Let's just swap the sides of this, so we end up with log base 2 of y plus 1, but for 1, let's write it this way. Let's write it as log base 2 of 2 for 1. And then with log properties here, we're adding, I can multiply them together and write it as log base 2 of y times 2, or 2y. So we have x is log base 2 of 2y. And then you can just swap the variables if you want. We have y equals log base 2 of 2x. And this is going to be our f inverse of x, but that matches this thing right here. So now that we've verified these two functions are inverses, next we'll go to the bounds. So just starting with the left one, we're saying b equals 2, a equals 1. What we want to find is, for this, we want f of b and f of a. So for f of 2, where this is our f of x, we're just going to have 2, plug in 2 minus 1, 2 to the 1. That's just 2 for our f of 2 value. And then for f of 1, same thing, plug a 1 in here. We end up with 0 in the exponent. This is just 1. So our bounds on this second integral line up with f of b, f of a. And so now that we have our f of b value, we have our f of a value, we can go to the right side and just plug in, do the thing I did at the beginning. And for our b value, we have 2, f of b 2 minus a value 1 times f of a value 1. Putting it together, 4 minus 1 gives us our solution of just 3. So there you go. I'll give you a link to the video where I derived this formula. It's not too bad. It's just really integration by parts will get you this formula. And in that other video, there is a few different ways we can show it. In the other video when I derived it, I had this piece on the right side of the equation, but we're just adding and subtracting things so we can rearrange them however we want. If we just had a single integral, it's probably more convenient to do it the other way and just have it on the right side. But since they gave us kind of two integrals, this is probably the better form to use. Okay, that's it for today. Thanks everyone for watching. Have a good day.